In section 8, we're gonna take 4-8 and we're gonna put it into two different parts. Okay, we're gonna start with part 1, and I'm just gonna introduce you to these numbers called imaginary numbers. For every number that you've ever seen through kindergarten up until now, you've seen real numbers. Okay, so just so you know, imaginary numbers, they're not real. Now, when I say that, I mean that they don't fit the category for real numbers. Okay, that means like they're hard for us to imagine that they exist, but yeah, they do exist, and we do actually need them. Engineers need them. They're in a lot of formulas that they use. The imaginary number was made to solve equations such as this: x squared equals negative 4. Now, you might think that x would have to be negative 2. But really, if you squared negative 2, you would never get a negative 4. So over here I'm going to write nothing squared is negative. Nothing squared is negative. So x squared equals negative 4 is something that we don't know how to solve. The solution to this, if we were to take the square root of both sides, we would get x equals plus and minus the square root of negative 4. Which, so far, if we've ever had a negative inside, we would just say this to be a not real solution. And that's how we would finish our problem. We'd say the problem is not real, and we would say we don't know what to do. But now, today, we're going to call it an imaginary solution. The square root of negative 1 is as basic as we can get. This is the most basic imaginary number, and we call it the letter I. So just so you know, anytime you see the square root of negative 1, that's the same thing as writing I. These two are interchangeable. Therefore, if you ever have a problem like x equals plus or minus the square root of negative 1, well, you would just write that plus or minus I. Now, there are different types of imaginary numbers. The first one we're going to talk about is something called a pure imaginary number. Now, a pure imaginary number just means that the number is just imaginary. There's nothing being added or subtracted. Okay, look, it is a single term. Each of those things in circles are one term, and they're each a pure imaginary number. Okay, now let's go ahead and fix a couple of these as we move along. The square root of negative 5, you're just going to say it's the imaginary root of 5. Okay, the square root of negative 7, you're just going to say that's the imaginary root of 7. The square root of negative 27, you'll write that's the imaginary root of 27. But this one, you're going to go one step further, because you know 27 is made up of 9 and 3. And you're going to take the 9 out, and you're going to say that's 3 imaginary roots of 3. Okay, so you're simplifying your square root. Now, a lot of students get confused. They think the negative sign comes out and becomes an I. If that's the way you want to do it, if that's how you can understand it best, fine. But really, you're just saying it's the imaginary root. But again, if you need to see it as the negative sign coming out and becoming an I, that's fine. Now, you guys know the square root of 81 is 9, right? Well, in this particular example, it's the imaginary number 9, so 9i. Okay, let's do 72. You do I square roots of 72. Now, what goes into 72? Hopefully you have your list. 36 and 2. Molly got Molly. Molly, move. Okay, so you're going to do the square root of 36 is 6i square roots of 2. My dog's helping me make my notes. Alright, let's keep moving on. If I is the square root of negative 1, and the square root of negative 1 times the square root of negative 1 is negative 1, that should imply to you that I times I is negative 1. Or, let's rewrite it, I squared is negative 1. Okay, that's going to be something foundational for you to understand. Anytime you see an I squared, you never leave it I squared, you make it a negative 1. Okay, since I squared times I squared is I to the fourth, because you add your exponents, and you know that negative 1 times negative 1 is 1, that should imply to you that I to the fourth is equal to a positive 1. Okay? Each negative 1 is just an I squared. Alright, let's keep moving on. That should imply to you even further that if you ever have an imaginary number to a multiple of 4, that's going to be a positive 1. And if you ever have an imaginary number to a multiple of 2 and not to 4, that's going to be a negative 1. I'll give you a couple of examples, okay? Let's say that we have I to the 96. Well, does 96 divide by 4? Hopefully your answer is yes. Okay, it's even. I to the 96 is a multiple of 4. Therefore, I to the 96 is a positive 1. Let's try one of these. What about I to the 6? Does 6 divide by 4? No. Does 6 divide by 2? Yes. The answer is a negative 1. Alright, so I have some examples here. Let's zoom in and see if we can figure them out. Anytime you have an imaginary number, the answer is just I. Leave it alone like that. Now let's say you have I squared. Remember, we said I squared is negative 1. Okay, what about I to the third? Well, isn't I to the third, I hope you agree, I to the third is simply I squared times I. Because I squared and I makes I to the third. Well, isn't I squared negative 1? So isn't this negative 1 times I? Which we can just fix as negative I. Okay, let's do I to the fourth. I to the fourth I taught you already. It's a positive 1. Well, what's I to the fifth? I hope you understand I to the fifth is made up of I to the fourth times I. And since I to the fourth is just 1, and we still have the times I, that answer is just I. Let's try I to the sixth. I to the sixth is, well, let's see. Let's break it down. It's a multiple of 2. Okay, but not of 4. Therefore, the answer to that is negative 1. Now, if you're struggling, why is that the way it is? I to the 6th is made up of I squared and I to the 4th. Okay? This is just if you're kind of struggling, like, why is that true? Well, guys, I squared is negative 1, and I to the 4th is positive 1, which makes negative 1. So you can see that my rule, that a multiple of 2 of not 4, does end up being a negative 1. Let's try some now. Let's try some more. I to the 8th. Well, what is I to the 8th? It's a multiple of 4, right? So your answer is a positive 1. Let's go through and see if we see any other multiples of 4. Not a multiple of 4, not a multiple of 4, not a multiple of 4, and not a multiple of 4. Okay, well, I also taught you about just multiples of 2. There's a multiple of 2 that's not a multiple of 4. Hopefully, you remember the rule I taught you. That answer is a negative 1. Now, these 3 are odd. Each odd problem, here's what you're going to do. You're going to back off 1, and you're going to say, well, 27 is 26 plus 1. You'll say 17 is just 16 plus 1, and you'll say 39 is just 38 plus 1. Now, why would I do that? Because we know about the multiples of 2 and 4. All right, every odd problem is going to have an I left over. Okay? For example, I to the 27th is made up of I to the 26th and I to the 1st, because 26 and 1 makes 27. I to the 26th, well, let's think, is that a multiple of 4? No, it's just a multiple of 2. So that's negative 1 times I, which is just negative I. Let's look at 17. Well, that's like I to the 16th and I to the 1st. What's I to the 16th? Well, it's divisible by 4. Yes. So that's a positive 1 times I. Well, a positive 1 times I is just I. Let's do to the 39th. That's I to the 38th times I. Well, is 38 divisible by 4? Not evenly. It's divisible by 2, though. So that's going to be a negative 1 times I, which is negative 1. Or excuse me, negative I. I'm going to make a chart that I hope will be helpful for you. Okay? Just make like a little tic-tac-toe board. Alright, now up here I want you to put, and these are all with dealing with exponents, alright? Okay, I would like you to put even here and odd here. Now, if the exponent is even, and it is a multiple of 4, the answer is going to be a positive 1. If the exponent is even, and it's just a multiple of 2, not 4, the answer is going to be a negative 1. Okay, now talk about odds. Remember, with odds, you have to back off 1. Back off 1. Okay? So let's say that we back off 1 and we get a multiple of 4. Well, if it's an odd, that means it's going to be a positive I at the end. Well, let's say that we back off 1 and we get just a multiple of 2. That's going to be a negative I. So you guys can see you have 4 options. With the odds, you always have an I left over. With the evens, you never have an I left over. Let's try a couple of examples down here. You're going to combine these just as if they were like terms. Okay, so this is almost another little section here. Combining like terms. What's 6i minus 4i? Well, just like 6x minus 4x, the answer is 2i. Not too bad, right? Let's go to example 4. I hope you see in example 4 that this absolutely needs to be fixed first. And I also hope you know that the square root of 25 is 5, but this is a negative 25, so we need to say it's the imaginary root, 5i. Then we have 8i, then we have 3i. Well, what's 5 plus 8 plus 3? That's 13 plus 3, 16i. It is essential that you fix the square roots first. Let's keep going. Okay, so we have a negative 8. Let's fix this. We're going to make that I square roots of 8 minus I square roots of 18. See how the negative, we're taking it out and we're saying they're the imaginary roots. Plus 4i square roots of 2. Well, I'm hoping that when you guys look at this, that you see that these two square roots, the square root of 8 and the square root of 18, need to get fixed. 8 is made up of 4 times 2, and 18 is made up of 9 times 2. I would just use that chart. So let's combine our like term. Well, let's go ahead and fix these now. What's the square root of 4? 2. So we get 2i, square roots of 2 left over, minus, what's the square root of 9? 3. So we get 3i, square roots of 2. And then this one was already simplified, 4i square roots of 2. Notice how you had to fix each square root before you can go on. Now ask yourself, does each one have an I? Yes. Does each one have a square root of 2? Yes. So let's do 2 minus 3 is negative 1, plus 4 is a positive 3i square roots of 2. Okay? If you're questioning when you can combine, let's write it down. You can combine if they all have an I, and if the square root is the same. Let's try another problem. In the next section, we'll cover about how to get rid of an imaginary number on the bottom.